Hello students! In this video, I will discuss the examples on your worksheet 3, which is all about problem solving on sampling distribution using the Central Limit Theorem. But before that, let me explain first the theorem and the properties of the sampling distribution of the sample means. Central Limit Theorem. If random samples of size n are drawn from a population, then as n becomes larger, the sampling distribution of the means approaches the normal distribution regardless of the shape of the population distribution. I know you're trying to wrap your head around this now since the definition is quite hard to comprehend, but let me ease this out for you in layman terms. For example, you want to know the ages of the grade 7 students in a given population. And since you cannot interview all students in that area, then you get a sample. From that sample, you get the average or the mean age of these students. This average age is called our sample mean. When you draw or when you make a histogram of this sample, it forms like this. Looking at this, you notice that there is no definite distribution, no? And the spread is way large. So the distribution is nowhere close to a normal distribution, since we know that one of the properties in a normal distribution is that the normal curve forms or tends to have a bell curve. No? I know it feels sad, but don't worry. Let's call Central Limit Theorem to the rescue. So as defined by the theorem, it says that when u increases the sample size, the distribution of this sample means follow a normal distribution regardless of the distribution of the underlying population. In short, according to this theorem, the larger the sample size, the more normal the distribution of sample means becomes. So to simplify discussions and examples, a sample is considered to be large if your n or your sample size is greater than or equal to 30. Now let's proceed to the properties of the sampling distribution of the sample means. So the mean of the sampling distribution of the sample mean is equal or the same to the population mean that is denoted by this symbol. So this is the symbol for the mean of the sampling distribution of the sample mean. We have mu sub x bar, and then our population mean is represented by this symbol mu. So for example, we have a population mean which is 20. So it follows that to get the mean of the sampling distribution of the sample mean, it is also 20, based on the first property of the sampling distribution of the sample means. Okay, now let's proceed to the standard deviation. So the standard deviation of the sampling distribution of the sample mean is also known as the standard error. So we have two cases here or two formulas to use. So first is if the population is finite. So finite means fixed. Okay? So we will be using this formula where the small letter sigma is the population standard deviation, small n is our sample size, and the capital N is the population size. But if the population is infinite, the standard deviation is given by this formula. So note that the relationship between the sample size and your standard deviation is inversely proportional, meaning class, or in other words, the larger your sample size, the closer your sample mean to the actual population mean. Okay, so that's it for our third property. As I discussed earlier, the sampling distribution of the sample means to tend to have a normal distribution regardless of the shape of the population. And this is supported by the Central Limit Theorem. So for example, we have a sample size of 50. So since it is greater than 30, it follows that the sampling distribution of the sample mean is normally distributed according to the Central Limit Theorem. Let's try our first example. A school has 900 junior high school students. The average height of these students is 68 inches with a standard deviation of 6 inches. Suppose you draw a random sample of 50 students. Find the mean and the standard deviation of the distribution of all sample means that can be derived from the samples. what is the probability that the random sample will have a mean less than 67 inches? I hope you mastered the topics on parameter and statistic because that is important as we classify numerical values with its corresponding description. So here's now the solution. First step is to list down the given information. So the population mean here is 68 inches because this is the average height of all the junior high school students. The population standard deviation is 6 inches. The population size is given, which is 900 in that particular school. The sample size, we have a random sample of 50 students. And then the sample mean is 67 inches. So the second step is to determine the mean of the sampling distribution of the sample mean. So applying the first property, we have the sampling distribution of the sample mean is just equivalent to the population mean. Hence, the sample mean is just equal to 68. So for the third step, we need to compute the standard deviation of the sampling distribution of the sample mean. But first, we need to classify whether the population is infinite or finite. So since the population size is given, which is 900, therefore the population is finite because it is fixed. So this is now the formula that we will be using. So just substitute the values in the formula, and then we have the standard deviation, which is approximately 0.83. Okay, so just check lang, double check using your scientific calculator. Okay, so for the fourth step, we need to standardize our given normal random variable, which is 67, by using the formula for z-score. So that is, our z is approximately negative 1.20. So we are asked to find the probability at most 67 inches. So we know that at most, meaning it can be 67 or less than 67. Okay, so we will be using this notation. So we will be looking for the probability that x is less than or equal to 67, which is still equivalent to the probability c is less than or equal to negative 1.20. And in order for us to get the probability, we will be using our z-table. So based on our z-table, the probability is 0.1151. Okay? So therefore, we can say now that the probability that the average height of 50 students at most 67 inches is 0.1151 or 11.51%. So for our second example, average weight of a newborn small breed dog is 212.5 grams with a standard deviation of 45 grams. What is the probability that the average weight of 59 newborn small breed dogs is at least 230 grams? So first is, we need to list down the given information. So we have the population mean is 212.5 grams, which refers to the weight of the small breed dog. The population standard deviation is 45 grams, the sample size is 59, and the sample mean is 230 grams. Step 2 is to determine the mean of the sampling distribution of the sample mean, which is just equivalent to the population mean. Hence, the mean of the sampling distribution is 212.5. Step 3 is to compute the standard deviation of the sampling distribution. So let's classify first if the population is finite or infinite. So based on this problem, the population size is not given. Therefore, we can conclude that the population is infinite. So we will be using this formula in computing the standard deviation. So just substitute. So that is 45 all over square root of 59. So approximately the standard deviation of the sampling distribution of the sample mean is 5.86. Step 4 is to solve the z-score of the given normal random variable. So 230, we need to standardize this one using this formula. So we have now 230, which is our sample mean, minus 212.5, which is the mean of the sampling distribution, all over the standard deviation of the sampling distribution, which is 5.86. So approximately our z-score is 2.99. And for our last step, in order for us to get the probability at least 230 grams, we need to use our z-table. So we have here at least. So when we say at least, that is greater than or equal to. So that is why I am using this symbol. So in our z-table, the probability less than 2.99 is 0.9986. But since we are looking for the area above or greater than 2.99, so we have to subtract it from 1. Why is it 1? Because we know that the total area under the curve is 1. So this is why we have 0.0014. Therefore, the probability that the average weight of 59 newborn small breed dogs at least 230 grams is 0.0014 or 0.14%. Now, it's your turn to solve these problems on your worksheet. Don't forget to turn in the worksheet in our Google Classroom before Saturday at 5 p.m. For questions, feel free to message your statistics teacher. Thank you for watching and see you in our next video. Bye!